If an astrological model assigns the exact same data profile to two infants born minutes apart, it fails its most basic acid test. Outputting identical results for distinct events means the system lacks predictive resolution. It does not have the mathematical sensitivity required to differentiate reality. Traditional Vedic astrology, known as Jyotish, operates differently. It is an architecture of rigorous computational mathematics. To solve the twins paradox, Jyotish utilizes an intersecting computational matrix, sensitive enough to isolate variables down to the minute of birth. The system discards generalized month-based archetypes in favor of measuring precise intersecting celestial coordinates. This computational grid is constructed on four specific pillars. The first two are spatial. Grahas are the planetary bodies and mathematical nodes. Rasis are the distinct 30-degree mathematical segments of the sky. The final two are relativistic. Bhavas represent houses, tied strictly to the time and location of birth, while Varga chakras act as high-resolution harmonic divisions of the primary data. These variables do not function in isolation. They form a strict geocentric coordinate system. Establishing this Earth-centric spatial geometry is the mandatory prerequisite before processing any astrological data. Measurement begins with longitudes, or sphutas. These are geocentric positions tracked across a 360-degree ring projecting outward from Earth. The standard Western model relies on a tropical moving zodiac. Due to Earth's axial precession, this ring continuously shifts out of alignment with fixed stars. Jyotish requires a completely static baseline. This is the Narayana, the fixed sidereal zodiac. Because modern astronomical ephemerides output tropical positions, the raw data must be mathematically corrected. We isolate the exact angular gap between the shifting tropical ring and the fixed sidereal ring. This specific calculation is the Ayanamsa. Without applying this Ayanamsa correction, the entire spatial architecture of a chart is flawed before the first planet is even plotted. With the sidereal ring locked, the geometry is sliced into 12 perfectly equal 30-degree segments. These strict divisions form the rasis, or signs. Next, we introduce the grahas. These are the celestial markers plotted directly onto this 360-degree grid based on their calculated longitudes. The dataset for grahas includes standard physical masses, mapping the actual orbital mechanics of the Sun, Moon, and observable planets. The dataset also incorporates strictly mathematical vectors, specifically Rahu and Ketu. These track the unseen geometric intersections between the orbital planes of the Moon and the Earth. Plotting both physical mass and these orbital intersection points onto the fixed Rasi segments yields the primary astronomical dataset. Processing this spherical celestial data mathematically requires translating it into a highly efficient two-dimensional grid. We examine Lord Sri Radha's chart. In the South Indian format, spatial positions are permanent. Aries is pinned second from the top left, with the rest progressing clockwise. Planets drop into fixed boxes. Here, the Sun rests in Aries and Mercury in Taurus. This grid functions as a static map. It preserves the absolute spatial locations of the planets within the sidereal zodiac, allowing the practitioner to read the geometry of the sky at a single glance. At this stage, the matrix holds absolute spatial positions. However, it lacks the relative geometry tied to the subject's exact minute of birth. The North Indian chart format provides the architectural solution for relative positioning. This requires calculating the lagna, or ascendant. This is the exact degree rising on the eastern horizon at the precise minute the individual is born. The North Indian format locks the lagna directly into the top center diamond. This anchors it as the first bhava, or house. From that central anchor, the remaining bhavas are mapped in a strict counterclockwise sequence. Establishing these bhavas creates a mechanical link. It tethers the slow-moving celestial data to the rapid rotational mechanics of the Earth. This specific calibration provides the mathematical resolution needed to differentiate two infants born just minutes apart. Beyond spatial geometry, the matrix also requires a precise measurement of angular velocity and time progression. Vedic chronometry ignores standard solar clocks. It measures time strictly through the angular differentials between moving bodies. We see this in the calculation of a tithi, or lunar day. A tithi is a dynamic value derived entirely from the exact distance between the Sun and the Moon. The system uses a modulo arithmetic equation. Subtract the sun's longitude from the moon's, take the remainder against 360 degrees, divide by 12, and add 1. This corrects negative values and divides the result by exactly 12 degrees to isolate the precise lunar phase. This algorithmic timekeeping tracks planetary phase relationships completely independent of generalized calendar months, adding another layer of mathematical resolution to the core matrix. With the computational grid completely mapped, the architecture is ready to output predictive logic. Every plotted graha possesses inherent behaviors dictated by its natural relationships, planetary dignities, and elemental composition. But spatial geometry alters those inherent baselines. The positional reality of a specific chart forces temporary modifications to how a planet operates. Temporary friends are calculated through geometric proximity. In the Sri Rama case study, we analyze the Sun in Aries. Geometry dictates any planet occupying the 2nd, 3rd, 4th, 10th, 11th, or 12th house relative to the Sun acts as a temporary friend. Spatial proximity calculated at the moment of birth forces planets into temporary alliances. These localized geometric vectors can completely override a planet's inherent, natural behaviors. The matrix's final state requires cross-referencing a planet's natural baseline with its temporary geometric position. This forms a compound relationship matrix, merging the two distinct datasets into a single output. For instance, if a natural enemy occupies a friendly temporary position, the intersection forces a neutral, or sama, output. Conversely, if a natural enemy is plotted into a hostile geometric position, the calculation compounds. It outputs an extreme functional adversary, known as an adisatru. This compounding matrix, applied across every graha, rasi, and bhava, yields an astronomical number of possible output states for any given set of coordinates, which brings us back to the twins paradox. Two infants born simultaneously in different locations, or minutes apart in the same room, yield completely different logna points and dynamic time variables. Jyotish succeeds precisely because it requires high-resolution initial conditions. It is a rigorous, interlocking matrix of celestial mechanics and modular arithmetic, engineered to measure reality down to the minute.